Hi, welcome to another video in GATE coaching. This is a problem that appeared in GATE 2021. It's a numerical aptitude type problem carrying 2 marks. I had already solved this in one method using surface integral. Now we are going to use divergence theorem and we are going to solve it using volume integral. We know that closed surface integral d dot ds is also equal to del dot d dv. In case of cylindrical coordinates, dv is rho d phi d rho dz. Now, here we have z varies from 0 to 2, phi varies from 0 to 2 pi, rho varies from 0 to 3. So let us find what is del dot d. Del dot d can be written as 1 by rho times dou by rho of rho d rho, that is rho component of d, plus 1 by rho dou by dou phi of d phi plus dou by dou z of dz. Now, d is given as rho cos squared phi a rho plus z squared sin squared phi a phi and no z component. So when we integrate it, now let us find out what is del dot d. That is 1 by rho dou by dou rho of rho d rho. D rho is rho cos squared phi plus 1 by rho dou by dou phi of d phi. Yeah. And then dou by dou z of dz is 0 here because there is no z component. So we solve what is this. Now rho times d rho is rho cos squared phi and d phi is z squared sin squared. Now we find what is del dot d here. Well, this is actually 1 by rho times dou by dou rho of rho squared cos squared phi. I'm substituting for d rho plus 1 by rho times dou by dou phi of z squared sinus z squared sin squared. Now, when you take dou by dou rho of rho squared cos squared phi is a constant with respect to rho, so it becomes cos squared phi by rho times 2 rho. The differentiate rho squared, you get 2 rho plus z squared sin squared phi. If you differentiate, z squared is a constant here, and sin squared phi is 2 sin phi into cos phi, that is sin 2 phi. So can further simplify this as 1 plus cos squared phi is 1 plus cos 2 phi by 2 times 2 rho here and here are 2 rho plus z squared by rho sine 2 phi. Now 2 rho gets cancelled. We get 1 plus cos 2 phi plus z squared by rho sine 2 phi. Now let us integrate del dot d with respect to volume. So integral del dot d dv can be written as integral 1 plus cos 2 phi plus z squared by rho sine 2 phi, whole thing times rho d phi d rho dz, because dv is rho d phi d rho dz. We have three integrals. Z is 0 to 2, pi is 0 to 2 pi, rho is 0 to 3. So this cos 2 phi and sin 2 phi terms, when you integrate with respect to d phi, and from 0 to 2 pi, obviously it becomes cos 2 phi. If you integrate and get sin 2 phi and you put values for 0 and 2 pi, for phi the same value, so integral becomes 0. Similarly, sin 2 phi, if you integrate and get cos 2 phi, cos 0 is same as cos 4 pi, so there also the integral becomes 0. So we are left with only one term, integral 0 to 2, integral 0 to 2 pi, integral 0 to 3, 1 into rho d phi d rho dz. Again, you have only rho inside, so to take integrating with respect to d phi from 0 to 2 pi gives 2 pi, and integrating with respect to dz from 0 to 2 gives you 2. So you get 2 into 2 pi, that is 4 pi into rho squared, rho d rho, when you integrate with the rho squared by 2, putting the limits, you get 0 to 3, top as lower limit becomes 0, upper limit is 3 squared by 2, that is 9 by 2, multiplied by 4 pi, that is 18 pi, which is 56.5 pi. And this is the answer. Thank you. God bless you.